Welcome back. So we have this given example. Here we have that a credit card company reports that the mean annual credit card debt for adults in a certain region is $6,200 with a standard deviation of $2,400. The company plans to randomly select a sample of 900. Now, to break this down, the first information we have is that the mean annual income, that is, we have our mean to be 6,200. Okay, and also we have the standard deviation, which is sigma, to be 2,400. So the company plans to randomly select a sample of 900. Here we have our n to be 900. To analyze the impact of the new financial education program. Now, the first question says, what is the probability that the sample mean debt? Now, if you look at this, our random variable is x bar. Okay, our x bar is the random variable, not x. So in this case, for you to get a probability, there's something we call the central limit theorem. So instead of using sigma, okay, in the case of the normal CDF, if you check the two previous videos I've done, you can see that I use sigma. But in this case, we're going to use sigma x bar. That is the standard deviation of the sample mean. In this case, we use the standard error, which is sigma over the square root of n. Likewise, for the mean, we use the mean of x bar, which is still equals to the mean. So there's a note on the central limit theorem. You can read more on the central limit theorem. So here we have this. So now, for us using the probability that the sample mean, which is going to be our random variable now, is less than, so we're using the less than sign, $6,100. Now, in this case, there's a need to draw the normal curve, as usual. Now, here, don't forget our random variable is the x bar. Okay? Now, here we have the center, which is 6,200. And looking at this, we want to see that our x bar is less than 6,100. So 6,100 is going to be before the mean. This is going to be 6,100. So less than means you are considering the area to the left. So the probability is to consider the area to the left. And don't forget, for normal distribution, we have from negative infinity to positive infinity. So in this case, the general form is to use the normal CDF. The normal CDF, the lower bound, the upper bound, the mean, and sigma over the square root of n. Okay, the reason why we have the sigma over the square root of n is because our random variable is the x bar. So we use the central limit theorem and we use the standard error instead of just the standard deviation. So here we have the normal CDF. If you look at the lower bound here, our lower bound is going to be negative infinity, and we use negative 1e99. You can check my two previous videos for more explanation on the use of the normal CDF. Comma, the upper bound, this is going to be my upper bound. This is going to be the upper bound, okay, which is 6,100. Comma, the mean, which is 6,200. And here we have sigma over the square root of n. You can do that separately out here. Sigma over the square root of n is the same thing as saying 2,400 over the square root of 900. And this is going to give you 2,400 over 30. 0 cancels 0, 3 here 1, 3 into 40 we have 80, yes. Or you can just press your calculator here. You can confirm 2,400 divided by the square root of 900. So you can see that is going to be 80. So here we have this to be 80. Now this is what we need to plug in the calculator. So to plug in, as usual, we press the second function and you come to distribution. So coming down to the next, to the number 2, here we have the normal CDF. And the lower bound is negative infinity as usual. And the upper bound here is 6100. Okay? The mean is 6200. And the standard deviation is going to be 80. Recall, we are not using sigma, we are using the standard error for this. So here we have our answer to be 0.1056. This is what we've got. 0.1056. That is, we have 10 points, or you can say that we have 10.56% chance that the sample mean depth is less than $6,100. Now, looking at the question number 2, the question number 2 says that what is the probability that the sample mean, look at this please, the sample mean is very important. The sample mean, which shows your random variable is x bar, is between 5,900 and 6,000. So now, drawing the normal curve as usual to help you determine this. So recall that our random variable remain as x bar. Now here we have the center. Okay, so here we have from 5,900 to 6,000. 6,000 will surely come before the center. So we are interested in the area between these curves. Recall, this is the center, which is 6,200. So we are interested in the area between these curves. And to do that, here we use the normal CDF. The normal CDF. Let me just move down there. We have the normal CDF. The lower bound is going to be 5,900, which is the starting point. The upper bound is going to be 6,000, which is the end point. And we have the mean to be 6,200. And we have the standard error, which is 80. So let's see what we've got. So second distribution, then you come to the normal CDF. Now our lower bound is quite different now. We have the 5,900 and the upper bound is going to be 6,000, yeah. 6,000. The mean remained the same, the sigma remained the same. So you can paste and see. Wow, we have a very low probability, 0.006, which is unusual probability. Yeah, this is 0.6%. We can call this unusual probability. Okay, this is not likely to occur based on the information we have. Now, looking at the last one, would it be unusual for the sample mean to be this? I would like you to try the last one. The only case you can have the unusual is the probability that your sample mean is less than 5,800. Okay? I want you to confirm this. If the answer is less than 0.05, it is yes. If your answer is greater than 0.05, it is no. Okay? It is no. So do this, put the answer in the comment section. Okay? Put the answer in the comment section and I'm going to tell you if you're right or wrong. But I would like to say something here. You see, for us to use the x bar as a random variable or to assume normality, there is a need for two conditions. Condition number one is that your sample size n must be large, that is greater than 30. Okay, if n is greater than 30, then you can assume your x bar to be normally distributed. Condition number two, if your observation x is normally distributed, I mean the population is normally distributed, automatically you assume that your X bar is also normal, even though if your sample size is very small. Even if n is small. Okay, these are the two conditions needed to assume normality. Thank you very much for watching. Watch out for the next episode.